Introduce our chief guest, Dr. Vijay Kumar sir, who was Mohammed accepted our invitation to join us today. About our chief guest, sir obtained his bachelor degree in electrical and electronics engineering in the year 2006. He secured all India rank took attend field in GATE exam and obtained his MTech degree in power system from MIT Tiruchirappalli. Also served after as a PhD research scholar with MHRD fellowship in the Department of Electrical and Electronics Engineering, MIT Tiruchirappalli, and completed in the year 2012. Sir, now currently working as an associate professor in the School of Computer and Electrical Engineering, Indian Institute of Information Technology, Design and Manufacturing, IITBM, Kanchipuram. Sir received N Scientist Award for Startup Research Grant, which was given by the SERDST in the year 2015. Sir is also the N Faculty Fellowship of Ministry of Communication and Information Technology since 2016. Now I warmly welcome you, sir.
In smart grid. So here the department is IT. However, when we go into that any scope domain of engineering that we have to leverage technology and we have to enhance the system. So that's what just here we are leveraging that IT and AI to enhance that performance of the smart grid. So here first what I can do is just I can give the brief overview of that smart grid. Then once we can understand that application, then we can leverage that technology, we can apply that and we can work on it. So that's what here. At first, I'm going to talk about what is smart grid and what are the technologies we are using in that smart grid and we'll discuss. Then we can move into the applications. Right? So when we come to that renewable energy, so even as a kind of big data, AI, ML, we can say that fancy words in that computer and IT. So in electrical engineering also, just we have that the fancy word, it's a renewable energy, or we are saying it's a green energy. Even you can evidence about this renewable energy sources in our, we can say that in our energy systems. So when we talk about that renewable energy, so here they are estimating that in 2050, you can the demand is almost 55,000 terawatt hour in a year. So that 55,000 terawatt hours of energy just be like I mean that's a demand. That demand means we can say that is the electricity demand. So the electricity demand also is one of the key parameter for the development of the country. So even if we are saying that even any country's electricity demand is increasing, then that's a sign of the development. We can say that development of the, or we can say that industrialization is happening. That's what we can say. People are talking about industry 4.0 and 5.0. When we talk about the industry 2.0, so the main key point is the electricity. So because of the electricity, the industry 2.0 comes. So now we are in the process of industry 4.0. So that's what we can say. In 2050, 55,000 terawatt hours of energy is required. So out of it, they are estimating that 86% of that demand going to be done by the renewable energy sources. Right? So that's what we can say. Even that every government they are focusing on the promoting the renewable energy sources. So this 86% of that total energy demand from the renewables. So if you are looking at that statistics, almost 1/3 of the power going to be done from that wind and another 1/3 we can say from the solar photovoltaic systems. So here we can see 6,000 gigawatt of the power we are generating from the wind and 8,500 megawatt of the gigawatt of the power from the solar photovoltaic systems. So these two renewable energy technologies are dominating. So that's what now we can see that even rooftop we are having the photovoltaic system. So that's what the government also coming with a lot of subsidies for promoting the rooftop PV systems. So here, it's okay. So here, why we are transforming? So why we are focusing much on this renewable energy system is the main objective is to reduce the carbon emission. So we can say at present level, 80% of the power we are generating from the fossil fuel based power generation units. That means we are using the coal and oil to generate the power. So here, another thing is to reduce the energy cost. So here in 2 decades before, if you see, if you want to generate 1 unit of power from this wind and photovoltaic system, it's 12 to 15 rupees per unit. That means 1 unit of energy, we can say, electrical energy. But now, for generating 1 unit of electrical energy, just they are paying around less than 2 rupees. We can say 1.8 rupees. That's a big example in the Ministry of Power. So 1.8 rupees of unit, 1.8 rupees per unit they are buying from the power producers, and they are selling to that consumers that almost 5 to 6 rupees. So we can say that 20 years back the cost is higher, but because of the technology, semiconductor technology, just we are saying that the power generation from the photovoltaic systems as well as wind energy systems are reduced. So if you are going to get renewable energy systems, so just we can have the greater economic gain. It's a win-win for consumers as well as utility side. And another is energy security. So why we talk about energy security? Maybe in an IT we may talk about network security, right? So the same way energy security here, just when we talk about energy security, is about the nation. So we can say that we are generating the power from this renewable fossil fuel power stations. Example, just we are importing the oil and coal from some developed nations or some developing countries. If any geopolitical issues happening, so that will create a lot of demand in the fuels. So, for example, 2 years back, there is a Russia-Ukraine war. So, because of that Russia-Ukraine war, what happened? So, there is a recession in European countries. So, what's the reason behind it? Because of the war, what Russia did is just they have stopped the natural gas power supply to the European countries, especially to the Germany. So here, I mean, they can say that 90% of the natural gas can be supplied by the Russia. Once they stop, so all the industries face the issues, right? So if any geopolitical issues happening, so just we will be in the greater demand of this fossil fuel. So that's what every country are focusing on that renewable energy sources, so that the sources from wind, sun, we can say that wind velocity or solar rotating is natural, right? So that's what just we are for enhancing the energy security of the country. Just we are moving towards this renewable energy sources and energy access. So here some of the rural locations, because here in urban areas we are having the distribution network, so just we are getting the power supply. So in India also, just we can say 3 to 4% of the areas are not connected to the electricity line. That's a we'll call as a distribution networks. So those areas, if you want to give a power supply, this renewable energy, by using this renewable energy sources, we can able to create the supply system. So that's what on top of on socio-economic perspective, if you look into it, we can able to create a lot of job opportunities in this field. So once if we can understand that requirement of this renewable energy sources, then just we can jump into the smart grid architecture. So here the smart grid architecture, if we talk about, just we in earlier days, when we talk about that power system networks. So in the power system network, we can say is the generation. We can see generation, then transmission, and we are having the distribution. So they generate the power in the power plants, and the power plants, the voltage level is you can say is 11 kV, right? So in the 11 kV, they can step up to 110 volt or 110 kV, sorry, 110 kV or 440 kV. They will step up and they will send it to the longer distances. Because once you have step up the voltage, you can able to reduce the losses. You might study in electrical circuits, right? So they transmit the power. So by using the transmission lines for the longer distances, and the distribution, we are having the primary distribution and secondary distribution. So in the primary distribution, just we can step down the voltage from 410 kV to 11 kV, and you are supplying to the industries or any commercial buildings, you can supply into that. And 440 volt. So that's what this we are getting in a room, right? 440 volt, 3 phase, and in single phase we are getting a 230 volt, right? So this is the power system structure. So in this power system structure, if you look at that, they will generate the power here and they will transmit and they will distribute to the loads. So the power flow direction is unidirectional. So there is no bidirectional power flow in this line. So only the unidirectional. So if any fault or anything happen, so just you will not get any electrical power supply at the consumer side. At the same time, the generation and distribution networks also will face the lot of issues. So even here there is no communication, only that you can have a phone communication, telephone, or you can have a letter with the entity. Right? So, but now if you talk about this renewable energy sources, we are saying the wind and photovoltaic systems. So this wind and photovoltaic systems, we are integrating into the distribution networks. So we can say that the wind, or we can say it's a PV. So just we are integrating into the primary distribution. So once you are integrating this wind and PV into the primary distribution, so what will happen? Because here we are having a big system. Just this will be in a megawatt. Even the loads, if you aggregate it, is also in megawatt. So here we are having the loads. So if we are having the industry loads and we are having the even residential buildings. So in these areas, if you look at that, here the loads, for example, in this particular room, so the load control is not in my hand, right? So suppose if you are here, then I can switch on the lights. So if I am not comfortable, then I can switch on the AC or fans, right? So the loads will keep on change. So there is no constant load. We can't expect that because this is a case of one room. Just we can consider that the region. So that loads will keep on change. So here the loads also will keep on change. And if you look at the wind and photovoltaic system, so wind and photovoltaic systems are intermittent one. So we will not get that constant power from this wind turbines or the photovoltaic panels. So this also is the variable one. So even today we might get the sunlight, so that we will get the power from that photovoltaic system. During night time we will not get, but during night time just we are having the very wind velocity. So from that we can able to generate the power. Right. So here that sources, the sources also is the intermittent one. So we will keep on change. So we can say that system is stochastic. So it is not able to meet up the supply and demand in the system. So if you are not able to meet up the supply and demand, so what will happen if you are not able to meet up the supply and demand? Then we will always have the stability issues in the system. So that's what people will use the forecasting of that wind and photo, let's say the solar variance. Based on that, they can able to do the energy management in the system. For estimating that wind and photovoltaic system, people are using some models. So in that, just we can use that machine learning or artificial intelligence by we can take the parallel models, then we can use to estimate the wind and photovoltaic system. So that we can able to meet out the demand. Even the demand also will vary. For example, if you are getting the rain, then that load pattern also will change. So if it's a cold, means during a winter season, the load patterns are different. During the summer, the load patterns are different. So this your system needs to absorb all these changes. Then only can make the system stable. So for that, we can leverage the AI or the ML models for precise modeling of the system. Right? So now this is a conventional power grid we can say. So here the power flow is bidirectional, but by integrating this photovoltaic systems and grids, we are having the bidirectional power flow in the distribution network, not in the transmission line. So we are having the power flow in the distribution network. So that's what just we are integrating this wind and photovoltaic systems into the we can say the distribution network. And here, if you look at that, we are in the segment, we are having the conventional power plants, and here we are having the integration of the photovoltaic systems and wind energy systems. And if you look at that consumer side, so consumer side, just we are having the factories, we are having the residential units, commercial buildings, and now people are talking about the electric vehicles, right? So now we can see that impact of development happening in this, load side. So here, when we talk about the factories, so in the factories, we are, people are talking about industry 4.0 and 5.0. So in the industry 4.0 is fully on the automation side, and industry 5.0, then just we can say is IT enabled industries. So here, when we come to the industry 4.0 also for automation, so just we are using the different communication protocols. So when we come to the industry 4.0, then we can have the RS-232, RS-485, and we are having a Modbus communication. So these are the communication protocols we used in the industry mesh nets. So at the same time, if you come to the codes, that's a residential building. So in the residential buildings also, we can say a lot of development. So how we can say the development means, even in the earlier days, in our home, we may have that incandescent lamps, right? So now we are moving to that incandescent lamp too. In the year of 1995 or 2000, people used to say that just we can move away from the incandescent lamps to fluorescent lamps, like we used to call it tube lamps. Then afterwards, just we come to the fluorescent lamps. So fluorescent lamp means compact fluorescent lamp. So just we are going to the CFL, compact fluorescent lamp. So why we are moving to the incandescent lamp to fluorescent lamp and fluorescent lamp to CFL? Then now people are talking about the LED lights, right? So what's the purpose of to shift to LEDs? But to save the energy, right? We can say the energy consumption we can reduce it, right? So now in the home, just we are moving to that LED lamps. So it's a kind of development. The same thing when we come to the refrigerators or air conditioners. So in the refrigerators and air conditioners also, in earlier days, just we have that middle AC, then we moved into that split AC. By buying that split AC, we may look into that star ratings, whether it's 3-star or 5-star rating. So then afterwards, inverter. Yes, exactly. Inverter driven ACs. That means inverter means it's not our UPS inverters. So here, for example, in a ACs, once the temperature reaches the set point, we can have the on-off, right? So if I say 22 degree, then if it reaches 22 degree, then your compressor off. Then when the temperature goes above that, 23 or 24, then maybe your AC will switch off. So, but now, if you are going to the shop, then salesperson used to say that you should go for the inverter AC. So the life is higher than the 3-star or 5-star rating. So, how we say that by going to that inverter ACs or refrigerators, we can enhance the lifetime. Is it so? But it's true. Whatever we planning that, it's true. We can enhance the lifetime of it. So example, how we can say that we are having a manual light switch, right? So how we can design that lifetime of the switch? So based on the use, right? Alright. So we can say that for one on off is a one cycle. So that switch might be designed for 1 lakh or 2 lakh cycles. So after the 2 lakh cycles, your switch gets spoiled, right? So the same way, here in the you are having the compressor in the air conditioners or refrigerators. So once the temperature reaches, then your on and off your compressor in the normal AC. Even in this AC is also just once the temperature reaches, you are off. Then temperature goes above that, then you are on the compressor. So the compressor life also getting down because of the on and off process. So in the inverter ACs, what they will do is they will use the variable drives. So in that motor and we are having the compressor. So in the motor, instead of on and off the motor, you are controlling the speed of the vehicles, right? So what's the reason? Even every OEMs manufacturer, they are giving that EV engine, right? Even the government also giving a lot of subsidies on that, promoting that EVs. So how we can say that EVs are efficient? So if you are using a car, so will you buy that EV by this time? Most of you say yes, and most of you say no. But when you are doing some calculation on this EV, by this time it's not really great. The reason is, I mean, the economic perspective. So if you are getting the car segment itself is a luxury. So in order to increase the price, then just we can go with the electric way. That's what people are buying the electric vehicles now, right? Recently, that Mahindra has released some EV version, so that's getting popular, right? So the reason is just only the look. That's what the Tesla made some breakthrough in it. So that's what all the OEMs are following the Tesla to release that various version of the EVs. So now, if you talk about the EVs, so that energy perspective, how we can say the EVs are good means. Now we are doing only that calculation from the tank to wheel efficiency. Tank to wheel means on the tank we will fill that petrol or diesel, then just we will run. So then we will see that how much efficiency we are getting, right? So if you compare the tank to wheel efficiency, then you can say that the efficiency is higher for the EVs because you are for the entire charging of your vehicle, you are taking some 150 rupees, right? So then we can go for 400 kilometers or 300 kilometers long. But here, if you look at the oil IC engines, so IC engines are not that much lucrative. The reason is just we have to pay petrol price and we have to fill the tank. But when you see into this efficiency of tank to wheel, then EVs looks very good. But when you go into the gel to wheel efficiency, that means where you are taking the oil and your efficiency on the wheels. So here, I mean, if you are taking the oil, so then crude oil we have to process. Just we have to send it to the refineries and we have to refine and just we will get that petrol, diesel and every byproducts and that petrol we are selling to the filling stations. And from that we are getting the petrol and we are filling it. But when you look at the efficiency, that well to fuel efficiency, well to big efficiency of the IC engine is, can say is 13%. Only whatever the oil you are taking from the crude oil wells, that energy is coming from only 13% on the wheels. But if you look at that, EVs, that is a 18%. So only that is a 5% efficiency is higher than the IC engine. So for that only, the government also is focusing much on this, promoting the EVs. So 5% is a huge number. We can say that 2 to 5% is a huge number, huge sale. So that's what they are promoting the EVs. So that's what the EVs are now speaking of, right? So now, EVs if we are talking about, just we can put some simple math here, then how we can leverage this area we are going to, right? So now, how much time we are driving our vehicles? Any idea? So now I'm the car. Any passenger vehicle in hand. So we have to rough calculation how much percentage of the time actually I'm driving my car. Just we can take 6 months time or 1 year period. So how much percentage of the time we are using it? Any idea? Any guess? Any number? 3%. So we can say that maximum we can do 8% of the time we are driving our car. So most of the time we are parking our car in our parking lot, in our office, or in our home, right? So 90%, we can say maximum we can take 10% of the time we are driving the car. So 90% of the time just we are parking our parking lot. So now, if you are talking about the electric vehicles, right? So in electric vehicles, you are having the battery and storage, right? So we are having the batteries in it. So earlier IC engines, so that's no use of it to use IC. Now we are having the battery. So in that battery, just we can say that in a home also we are using the battery for the UPS, right? So when the power goes off, so 2 to 3 hours you can to switch on to 4, 5 lights with the bulb. So it's a kind of energy storage device. So now the question is, now for a single vehicle, just we are having the 500 ampere, we can say 500 kilo ampere of battery. So 500 kilo ampere hour means we can take the 500 kilo ampere for 1 hour. If you are taking the 500 ampere means for 30 years. 30 hours. So this is what the battery means, ampere hours. Right? That's what in a mobile also we are saying is 3000 mAh, 6000 mAh, right? So the same here also we are having the kilo AH, right? Kilo AH. So now this is what one vehicle, right? That's what one vehicle. So now in your apartment, you can say 100 people are there. Out of 100 people, 80% of the people they are using they are having that car. So out of the 80%, you can say 40% are EVs, 50% are EVs. So again, we get that. Yeah. So that's what this there are technologies coming in the picture. So because of these technologies, you can able to make your system smarter. So here the smart grid is not a new title or new system. So just we are having the same conventional system like this. So in this we are adding the features. So once you are adding the features, then we are making the system as a smarter. Then grid also the same. Just we are so if we want to make that system smarter, then just it must have the communication among all the devices. Or we can say that all the devices in the system must have the communication among the other devices. So just we have to establish that we have sensor as well as we have to establish the communication with the clouds for communicating with these devices in the system. So when we talk about power grid, so power grid is a very large network. So it's not a simple network. It's not a simple application like if you are saying it's any healthcare application, so in a healthcare just we are having some specific problem. But here when you are going to that power grid to make that grid as a smarter, then you must know each and every part of that system. Then only just we can identify that potential where and to implement that IoT or AI into the system. So that's what I'm giving that overview of that grid and how we can be able to make that grid as a smarter. So for making it smarter, just we have to establish the communication among the different devices.
The ultimate aim of market is to save energy and the cost of acquisition.
What is energy efficiency? So that's the main objective. Out of it, just we can say reliable operation. So reliable operation means if I'm here, so if I have the communicate now, at least power supply is not in a home for 3 hours or 4 hours, at least now we are getting a message. So there is a power cut from this period to this period in your location. So earlier days they will not send any even messages from. So sudden power cut, you cannot have the power, you can't do anything. think of it. So earlier also, as a people industry, can go and the tickets in the ticket counter. So now just we can do the tickets on your mobile, right? So your smartphone. The same the electricity also. Just if we need discussion, or if you are having the devices in your home, you can have the flexibility to control the device.
But
So yeah, yes, based on that, look pattern will change. So, for example, summer, most of the folks we are using the academic. So that even now it's also during a summer we will reach that maximum peak. So even now we are having a capacity of 1,000 megawatt. So if you are going more than 1,000 megawatt, for example, this institute or any industries, they are having the maximum cap. For example, in our home, individual home, we can say it's a 6,000 6K kilowatts. So if you are going more than 6 kilowatt, so we are not having any system to measure it. But in this case, we are having the panel. In the panel, they are having the circuit breakers, relay, and everything. So in that, we are able to see that how much current reach. So if you are reaching above that level, then we have to pay the penalty. So why only on the summer means we switch on all the air conditioners and fans. So in our residential and commercial units, the main culprit is the air conditioners, fans, and whatever high power devices. So lights we now we use in the yeah. No, seasonally it will change. Even rain means. So in a home we will not use fans and that. No, loss also is having the transmission lines. So when the power demand, for example, here I am having a 5,000 watt demand. So for 5,000 watt, I can say my loss is 20% the transmission distribution. So the 5,000 20% we are having some value. So during the seasonal, I can say only 1,000 watt I use. So for 1,000 watt is the 20% is on number. Right? So that way it's clear. So demand, if you are reducing the demand, then the loss also will be reduced. So again, AC is no, not about summer and winter. How much demand? Demand. So only you can say that transmission system loss of 20%. Irrespective of the demand, then we can say 20% loss. Yeah. No, that is that's a different thing in transmission losses. We are having different losses there. So because of course they say the corona losses. So that's what they are using bundle connectors and the space between the connectors also they have to manage. Otherwise we are having a magnetic field around that. So that magnetic field will interact and there is a chance to short circuit. So that's what the spacing of this matter between the connectors. And what type of connectors they are using. So if you are using aluminum, the losses are higher. Copper, if you go, the losses are less, but the cost is higher. So just we have to trade off to select the connectors also. Right. So now, if we talk about the role of IoT in the smart grid, so earlier we are having a passive communication. So in that passive, just we can say we are using RFID and QR code. So these are we can say the passive communication. Then active means just if you are doing the automation in a home. So whenever the communication is needed, then your sensors will play. Just we can ping it to the network and we can get that information. And then now they move to that awareness. Just they are integrated awareness. So here the awareness is a kind of telesource. So if you are pressing 1, 2, simple computations. It's not much computation, only the conditional check. So after conditional check, just we will get the information. Then autonomous. So when we go into the autonomous, just we are making the decision. I mean, your system should take the decisions. So if your system is taking the decisions, obviously just we need the algorithms. That algorithms will be writing based on the rules, right? So which are conditions. So based on the conditions and rules, you can able to make your system autonomous. So we can say that autonomous car and smart grid are clearly some of the picture. So in this, your system should have a handle to take the decisions, right? So we cannot do it manually. Even the autonomous cars, if find any obstacles, then it needs to take the decisions, right? So in that case, just we have to apply the rule-based algorithms. So based on the rule-based algorithms, we can able to make this kind of applications. Right? And when we talk about the IoT, Internet of Things, that the major application of the IoT in the homes. So that's a major application. So that's what the IoT is taking popular. The reason is if you are talking about smart homes, smart cities, or smart buildings, then the IoT comes in the picture. So that's what we can see that smart homes, we are having the 100% potential of the IoT devices. Here, how we can say that smart home means one is I talked about the air conditioners, refrigerators. Even if you are having any LED TVs, everything you can able to connect to the single network. So, for example, earlier case, if you want to make if you want to use the TV, then you have to subscribe the TV, right? So, earlier they use the cables, then they go into the DTH, right? So now we are using a DTH for TV, watching a TV channels. No, we are going to the satellite TV. That's a satellite TV. That's okay. But now there's a trend. We are not using the DTH to watch our TV. Yes. Now we are going to the OTT platform, right? So we are having the Disney on Netflix, and we are having the Amazon Prime, right? So OTTs. So if you want to use the OTTs, then what you require? You need an internet, right? You need an internet connection. So earlier the internet connection, internet connection that's a dedicated line, and for your DTH it's a separate line, and for your landline you are having a separate line. For mobile you are having a different line. But nowadays we are having the bundled offers that whether you can take Airtel or whatever the protocols we are using for home management system, many protocols cannot use it for industries. So because of the security. So they are having their own protocols. That communicate protocols also compatible with the particular machineries and devices in the industry. So and security, reliability, everything they can look into that. So what some of the communication protocols we are using in the industries. The next one is connected cars. So connected cars also is very much better. Why the connected cars are very much better means now we are talking about the driverless cars, right? So autonomous vehicle. So once everything is autonomous cars, we can say to everything that cars each other, then your cars must be connected with the other cars. So the communicate, if any emergency, you can able to communicate with the neighbor cars. Even in a higher cars, like if you are talking about BMW or Audi, even Tesla, they are having the connected cars concept. If you are 10 kilometer radius, what are the cars that are able to connect to those cars? So this is not for sensor cost concept reducing. So we can able to deploy a lot of sensors in that for measuring the voltage, current, and temperature, even for measuring the different gases. So the sensors are very cheap, so we can able to deploy a lot of sensors into the system. We can able to get very good embedded processors or microcontrollers at the price of 500 or 400 rupees. So the processing, that's what once the processor cheap, then we can able to process the data. And usage of smartphones. So it's a drastic change in the smartphones. So because of that, we can able to automate everything, even the services if we talk about. For booking a tickets, we need not to rush to that ticket counter. We can avail that ticket booking on your mobile. For at the same time, the services, whatever the services for gas supply or anything, even the groceries now we are buying them online, right? So e-commerce also is getting popular. So that's what this we can say that controlling the devices and making the smartness in the device also is better. So that's what we are moving towards. And the wireless coverage. So now we are talking about 5G. Even the 6G also they are working on it. Even if you are going full-fledged 5G, then you can able to get huge internet speed and network speed. A lot of requirements from the consumer side as well as in the utility side. So that is possible. So that's what just now we are moving to this IoT. So when we come to that IoT and smart grid, so without these IoT devices, we cannot see that automation of that grid. So here the main purpose is just we are deploying the sensors and we can make the communicate among them and we can fetch the data, process it. After processing it, we can take the decisions, right? So this is for control aspect. So if we come into that monitoring of that grid, then of course if you are having the data, with that data we can able to do the monitoring. So everything we can able to do it. So when we come to the IoT, so whether it's a things oriented, so what are the device you are using to the system, that devices are compatible to connect to the network and internet oriented. So which network you are connecting to it, whether you are connecting to the local area network or you are connecting to the internet. So that is network based and the software. So when we talk about the software, whatever the node devices you are using, so that node devices must have the firmware to compatible with the devices which you are connecting to the home. So that firmware oriented device also is important when we come to the IoT platform. So here when we say is communication and power network is both are different areas, different network we can say. So people working in that technical area, they won't have much knowledge on that communication. But when we come into that smart system, we can say so smart grid or a smart home, then the smart grid if you say, then we can say it is a power network and is a communication network. Just we have to integrate this communication network in that power network and we can able to make our conventional grid as a smart grid. So we can explore a lot of communication technologies in the power network also. So there are various definitions from the mission of the grid. That's it, right? So all the definitions are almost same. But here in the smart grid, in which area you are working on? Whether you are working on that generation side, transmission side, getting a lot of signals from that, then you can take the decisions and decisions means you are not making the decisions, even your system taking the decisions. So that we can say you can able to optimize that which energy sources should be utilized maximum. So that we can say that if you are having the wind and photovoltaic systems, then your system can give a decision that you can utilize the energy from the wind and photovoltaic system. So in that case, you can say your grid is clean and greener. And here, the efficiency of the system, you can enhance the efficiency of the system as well as reliability. So that you can say that your system is autonomous. So that's what the purpose of integrating the sensors and communication among the various devices in the smart. You need not to have the human interference in that. So if any fuse or any circuit breaker is faulted, then if you are having a very intelligent system, so that can clear the fault and can restore the power within a 5 to 10 minutes of time. Otherwise, no, you have to wait for hours to get the human come into place and to resolve that issue. So that we can say self-healing, and we can say that obviously if you are having the networks and communication, then cyber attacks happen. So just we have to go with that cyber security of the networks, in the network side as well as in the software side. And consumers, so as we are the consumers, we can also participate in it. So that's the leverage we are getting. I mean, we can say that because of the, so that's what the network can accommodate, and it will open up a lot of new avenues in that electricity market, and the assets which we are having in that generation side and transmission side can effectively utilize that assets, and we can provide the quality power. So quality power means it's not 24/7 continuous power, that's a reliable power. So if you are saying it's a quality power, if I say it's a 440 volt or 230 volt, you will get that 230 volt even if you are having any loads connected to the network. So you will get the 230 volt constant 50 Hz frequency. So that we can be able to get once you are integrating these IoT devices, so that we will get the constant voltage and constant frequency that will be used for the consumers. Why means if I have any electronic gadgets, because of the voltage and the frequency fluctuations, that might get chance to get damaged. So if you are having a constant voltage and frequency, the failure of these devices in the network as well as in the home appliances are less. So that's what we need, the quality power and operating efficiency of the grid. So that also is possible. So once you are having, there is no demand here, then even here it's not like our UPS. So within a second you cannot be able to get the power. So if the power demand goes very low, you cannot be able to turn off the generation units, because once you turn off the generation units, that's a 500 megawatt power plant, you need a day to start the generation units, right? It's not as simple as like our small systems, right? So in that way, just we can say, sorry, so in that way, just we can able to make our grid efficient by integrating these IoT devices. And when you come to the smart grid platform, in the information, we are having the communication line as well as power flow lines. So in this information flow, if you look into that, when you come to the consumer side, we are having a whole area network. When you are coming to the distribution network, we are having the neighborhood area network. And when you come to the generation side, it's a wide area network. So that's what having the different communication technologies we are using to the distribution, consumer side, and the generation side. So here we are having the different devices. So these different devices will be connected to that particular communication area, so that we can able to have in a home area network, we are having a lot of sensors and the small communication protocols like Zigbee, LoRaWAN, and you are using a Bluetooth, RFID. So this type of so that's what they have come up with that green data centers. They can come up with their own resources like photovoltaic system and all for powering up these data centers. And they are having the diesel generators every backend. So for that we have to design the system, and with that they are integrating into the city. So that we can say the data centers also plays a huge role in the smart city project. So when we talk about that home automation, so these are the IoT devices normally we are using. That's what we are saying, that why we are spending huge amount of money to buy that smart devices means not only for the fancy purpose. So there is a huge energy savings, as well as we can say that is a win-win for the consumers as well as the utilities. So for example, how I am saying is, if you are saying 1 unit of energy at the consumer side, it's equivalent to 100 unit of coal they are burning. So that means for us it's a 1 unit, it's very simple. But look at that utility side or the country side is a huge, right? So even we can say it's a 20% or 30% of the cost they are giving as a subsidy for getting as a scheme. So that's what they are looking for, the energy conservative measures. So that's what, once you are carrying these smart devices, you can able to, for example, if you are having the I not use tariff, then I will not waste the electricity. For example, I will not switch on my washing machine in the peak hours. So what I will do, I will schedule it. So because once I go and I can go, so during that 12 hours, whenever the electricity price is lower, so that time your system can make to use of it, so that your electricity bill also will be reduced. At the same time, they need not to go for new power plants, right? So it's for, and talk about washing machine of 1 unit. Just you can consider that entire region and the Chennai, how many washing machines, right? So that will give some meaningful number. So that number can be helpful for consumers as well as utilities. So they do not need to go for the new power plants or new facilities. So that's the same for the utilities. So that's what this IoT plays a huge role in the smart home and smart buildings. Right. So these are the various devices we are using it. So one is for display GUI purpose, and some of them are sensors, and some of them are node devices. Node devices means the simple embedded controllers. Right. Yes. Next one is if we talk about the smart metering, the privacy issue also come in the picture. So how we are saying privacy issue means, actually the Samsung they come up with one project with the OTT or they are having the watching the TV programs. So even in a OTT also we can able to see that if you are watching some movies or some shows, we can say. So if you are watching one show or movie, so that will give the suggestion that, so just you watch this movie, so these are the recommended movies for you, like that they are predicting. That means that they are looking at you, right? So they are seeing that what movie you are watching. So based on that they will give the recommendations, right? The same way in a home also there is a security. I mean, this for they are doing for a business perspective. But you can see that in a home, you are having the energy meter. So once you are connecting the energy meter to the network, so is it possible for me to extract that energy usage pattern? So by looking at the pattern itself, I can say that there are people are in a home. Here, for example, if I am going out for 4 months. So in the 4 months, the pattern is totally different, right? So I can see that whether people are in a home or not. So there is a security threat to the home. At the same time, in a business perspective, if I look into it, I can able to easily predict that what are the devices I'm using it. So which refrigerator I'm using, what type, which brand air conditioners I'm using, whether I'm using a refrigerator mode or lighting mode. So based on that, the business people come into the picture and they will sell that their products to you, right? So that is possible. So that's what I say. By looking at this pattern, I can say that which device we are using it. So whether I'm using a refrigerator, when I'm using an oven, then when I'm using that heaters, cooling purpose. So these devices I can able to easily get, so that they will do the actually some other slide changes. Center button is for the pointer, so that's what I'm confusing with that. So now here is for moving. So here just I'm by looking at this pattern I can easily able to identify the devices. So for this and all, just your A come into place. So for giving me suggestions, right? So just by using that data driven models, then we can able to do this kind of predictions in the smart metering data, right? So here again the regulators come into the picture and they have to say who can able to access your data and who should not, and when they can able to access the data. So that kind of related measures should be taken care of it. So even there is a chance to have a malicious attacks on that network. So people might ask that, so if I'm connecting all the devices, there is no privacy on my phone, right? Even you can see some ad also I have seen recently. Just your phone is, they use the smart lock with the voice assistant control, right? So the person getting called and he is saying that open the door, so that your system is not recognizing your voice, so the person could not able to go and enter into that room, right? I think you might have seen that ad, right? So this kind of limitations also there, even when you are making that smart attendance system. So smart attendance system, just you have to stand at least 1 minute before that face recognition attendance system. So otherwise, if you are moving or if your back lightings are not there, then the accuracy you cannot able to get it, right? So these are the limitations, but we are having a very good processes. By enhancing the process, you can do it, but the thing is that cost, that also is a matter, right? So same way here also, people might think that once you connect all your devices, there is no privacy. Even if you are using a mobile, it's not, whatever the data in your mobile is not yours, right? So anyone can access it. That too in an Android, anyone can access it, right? So the same thing is happening that's a, yeah, there is a merits and demerits. But here again, we are talking with the reliable system for this. Here the battery can charge and you can discharge. But if you consider this, you can able to only charge it. You cannot able to discharge it, right? So that's a limitation of this virtual energy storage, right? So here for estimating that virtual energy, then just we can get whatever the loads we are using. So how many refrigerators and air conditioners we are using. Then you can get the time constant of the refrigerators and air conditioners, and that large time constant loads you are fetching from the home. So that matters how much time you are using it. So how much time when we are using it. So what is the size of the PV and energy storage system. So you can collect all the data, and based on that you can have the data-driven model. And that data-driven model you are deploying in the cloud, and you can able to compute the virtual energy storage estimation. That estimation you can do it for the cost benefit analysis. But cost benefit analysis is not required in the real time. But when you are implementing it, you have to do the cost benefit analysis. So without doing the cost benefit analysis, we will not go into this model. So here by using this data-driven model, so if any changes happening in the loads also you can able to easily capture. At the same time, if any devices are getting aged, that also will be modeled in the system. So that also will be considered while modeling the entire energy system. So that we will get a very precise model for estimating this virtual energy storage estimation. By doing that virtual energy storage estimation, we can do the cost analysis, right? So in addition to that, by doing this, we have to see the occupant comfort also. That also is matter, because if you are saying that the occupant comfort, for example, for saving the energy, I do not set the temperature as 25 degree for all the time. So for 5 minutes or 10 minutes, I can set it as a 25 degree. But I am comfortable with the 22 degree centigrade. These things we are using the sensor. Earlier we are using the motion sensor. Instead of that, by capturing that frames in that image, then I can able to take the decision. So for that we must have a very good processor to sense that image processing and take the decision, right? But now what we have done is our work. So in the occupancy detection itself, we are having the passive method and active method. So in the passive method, we are having the sensors. So in that direct and indirect of that, then we are using the sensors. In the active method, just we are using the wireless devices and the wireless technology. Suppose if you are saying it's RFID, so always you have the tag with your packet for RFID thing, right? So we have to access the door or access. We are having the Wi-Fi router, right? In the Wi-Fi router, so what are the information I can get it from the Wi-Fi router? So how we can see the signal strength of Wi-Fi? Any idea about that? About CSI data? What is CSI? IT might have networks. CSI, channel strength information. No idea? Huh? Yes, RSSI and CSI. Both are there. So we are having both the data you can able to get it from the router. So RSSI as well as CSI data. So by using the CSI and RSSI data, you can able to identify the human activity. So very simple. So if you are walking, that data pattern will be changed. CSI pattern will change, CSI or RSSI. Then if you are sitting, that data will be different. So by using the machine learning models, you can able to identify the human activity, whether you are sitting or standing or walking. So actually just one of my research scholars worked on this field, human activity recognition, by using CSI and RSSI data from the Wi-Fi router. So you can able to identify the human activity, how many persons are staying in the room and what is the activity of the person. Actually we published that in the transaction measurements and instrumentation. So if you are really interested on that, you can refer that paper, so you will get more insight on that. So in that, what we claim is, we are saying that sensorless system for human activity recognition. Why we are saying it's a sensorless system means, if you are taking any room, we are using the Wi-Fi router. At the same time, if you are saying the smart home, we are having some embedded controller, ESP32 device we are using it for controlling the on and off that lights and air conditioners. So with that ESP32 device can control the devices, as well as that will normally if you are using ESP32 device, that can be connected to your Wi-Fi router, right? So that can be connected to the Wi-Fi router. So by measuring that, by getting the CSI and RSSI data of that ESP32 device, we can do the machine learning algorithms. By using the machine learning algorithms, we are identifying the human activity. So by using that human activity, we can able to control the lights as well as appliances. At the same time, we can use it for healthcare applications. For example, if any bedridden people are there, so if he is standing or walking, by monitoring them also we can use that one. So healthcare as well as controlling the appliances. Because with that interferences, that's what we have done that work with only with the CSI and RSSI and with the CSI and RSSI to confirm that, to enhance the accuracy. So with the both we have the CSI and RSSI data, if we are using it, that percentage, the accuracy is higher. Practical actually just in a practical just like finish it and I come to the So with that we can able to identify the human motion. So that's what the machine learning algorithms plays the huge role. So here with the existing infrastructure, already infrastructure is there. So only by collecting the CSI and RSSI data, we are able to identify the human activities. So that activity can be used for controlling the appliances as well as monitoring the queue. Here, as you said, here just we are having the Wi-Fi fingerprints as well as RSSI, CSI data we are collecting it. By using the CSI and RSSI data, just we are using that ML algorithm. With the ML algorithm, so we are predicting the human activities. So here, thing is that it's a non-invasive. So we are not having any electronic chips. In a lab purpose, what we have done is just we have collected the TSI and RSSI data from the ESP32 device in the Excel format, and we have used that data for modeling the system. So we haven't done real time with the same, because in the ESP32 device is a 500 rupees node device. So with that we cannot put the ML model to that and identify the human activity. So what we have done is we are collecting the CSI and RSSI data from the different human activities, and we collected the data and we processed.
For example, the ranking of places, the RSSI level is 90%. When we move away from the places or if we are walking, then RSSI is getting up and down.
Yes,
It definitely creates some kind of errors.
that's kind of errors. That's what we aided this one with the CSI data. So CSI data also will give. So confirming, we use the CSI data also to confirm the accuracy, so that the accuracy level is higher. So if you are using only RSS, yeah, there are papers they are using only RSSI data alone, and some papers they use CSI data. But our thing is just we have combined together and just we confirm the accuracy of them. So in this case, just we are using that various communication, the same thing. So Zigbee, LoRaWAN, and we are using Bluetooth, RFID, and everything in that collecting the data, and we can go with that which protocol we need to use. But here again, we need to establish the infrastructure for this. But whatever we proposed is just we are having the Wi-Fi router and ESP32 device. So from that we can able to control all the devices in the home. So the control is possible by doing the integration of the IoT. Then in the IoT, what we are planning is with the existing infrastructure, we can able to add these features into the home management system. So that's what our plan. So we need not require any extra infrastructure for implementing this techniques. So this will give the overview of our work. So if you want more information on that, these papers might be available in that IEEE transaction on instrumentation and measurements, and another paper in embedded system lectures, and another paper in IEEE renewable and sustainable energy review. So these three papers will give you that very detail of this human activity recognition by using a RSSI and CSI data. Right. Any questions? Actually, we may not require any lab setup for this kind of work. Actually, that's what we prefer to work on this IoT area, frankly speaking. The reason is not, actually I am learning through electrical and electronics engineering. So if I want to do this kind of setup, I need 5 crore rupees to set up that for each and every device. So here we are having, the thing is that here we are having the various devices. First we have to understand the system. So that's what I have given that much emphasis on the beginning, that we have to understand the system. So we have to emulate the data, or we have to get the data from the smart meters. So with that data, we can, because for implementing these things, we require only 500 rupees ESP32 device. So that ESP32 device we can bring, and then in our lab itself we are having the Wi-Fi router, connect it, and we can do the practice for walking, standing. But you need to spend a lot of months time to collect the data. That's the only thing. So just we can collect the data for the different conditions, and collecting that data, after collecting the data, we can model it. So by using the existing model in the literatures. So here we need not to have much infrastructure for human activity recognition. With almost we can say 5,000 to 10,000 rupees you can do the results. So that's a advantage of implementing the ML models and the AI into the electrical engineering. Because we can't work in the rail system, even we can't make the rail prototypes in the lab, in the engineering, electrical engineering side. But in the algorithms and all, we can do it because we are having normally C does this work on Python. So just see calculate the data, let's see work on the algorithms. Only the algorithms are So that's the thing. But here we have to understand the system. Application. That's very much important. So here, when we go into the real time, maybe some data might change. So your models should adapt that changes that happen in the real time. So that for deployment is totally different. So for deployment, we have to put a lot of effort to come up with the products. For research purpose, we are having a very good track. If you are talking about our server or we are having how we can use it, and that and all is okay. But when you are going to the field, you are going for commercialization, then price will come to the picture. So yeah, that's it. Part of the smart grid, that's it. This is the load. Actually, no. In an electrical engineer perspective, I consider industry as a load point. They are consuming the power from the grid. So I consider that as one load. So in that load, they are doing some developments over there. That developments are, we can say, is the industry 4.0. So it's some tiny part in the smart grid. It's a load. That load we are saying is the industry.
More on multidisciplinary departments. Okay, so even for funded projects, they are encouraging only interdisciplinary projects. So that is why I have chosen topics which is related to the other department, electrical, electronics. So those topics I have chosen. So where we didn't explore, so if they throw some ideas, maybe like some thoughts might linger in our mind and we may work more on those areas. So only we have chosen those topics. So I think sir has given, he discussed his paper. So I think that will also be useful for your research work as well. So thank you so much, sir. As a token of appreciation, we would like to give this memento to sir.